Okay. So, you can have moles of atoms, but like I said, you can have moles of molecules. You can have moles of ionic compounds and moles of anything. So when we talk about the moles of materials, if we talk about the moles of atoms, we can call it the atomic mass of the atom. If we talk about moles of molecules, we don't want to call it the atomic mass. We'd want to call it the molecular mass. And if we had moles of an ionic compound, we wouldn't want to call it molecular mass either. We'd want to call it like the formula mass. You could also call it the ionic mass, but formula mass is better. In fact, formula mass is very general. Any chemical has a formula, or any atom has a formula. And the most general of all is what we just call the molar mass of some material. So, what is the formula mass for barium? Oh, I should have asked you. What's the name of this compound?
I can't remember the PO4.
So what are you supposed to do when you come to a compound that you don't know the name of?
I need to look it up.
That's right. Where would you look it up?
On the back of the periodic table.
That's right. So here it is, the back of the periodic table.
Phosphate. Barium phosphate. That's that compound.
Very good. So, what's the formula mass of barium phosphate?
Can you show me the periodic table? I need 3 bariums. I have 2 phosphoruses and 8 oxygen.
Very good. You know how many elements we have based on that statement in our exercise, right? We worked hard on that. Now you can also, down here, and generally moving forward in problems or in slides.
Oh, the masses are given.
That's right. We have the masses. So use the calculator, 3 bariums, 2 phosphorus, 8 oxygen. See if you can get the right value. Okay, hopefully you tried that at home, and hopefully you got that number. Now, here's another chance. Again, knowing the name of the compound. What's the name of the compound, Fred?
I need the polyatomic ion chart. Wait, I know that first one. That first one's ammonium, but I don't know the other one.
Okay, let's see if we can find it on here. There it is.
Carbonate. Ammonium carbonate.
Very good. So we got ammonium carbonate. Count up the number of nitrogens, hydrogens, carbons, and oxygen. Add their masses together, provided the information with the information provided there, and make sure you can do that correctly in your calculator. Did you get it, Fred?
No, I don't have a calculator, and I don't have. I don't want to talk about it.
Okay, so you did it at home. Let's see what the answer is. 96. All right, that's 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens. Okay, very good. So, if I know that the molar mass of carbon dioxide is 44, that's grams for every mole, how much mass of carbon dioxide is found in 1.55 moles? Well, this molar mass can be used as what we call a conversion factor, right? We can use it as a conversion factor. We answer this question by looking for our units that we're after. What units are we after in this question, Fred?
Grams of carbon dioxide.
That's right. Very good. Grams of carbon dioxide. What units are we going to start with?
Moles.
All right. It's not enough just to say moles, though. What do we got to put there?
Moles of carbon dioxide?
That's right. Moles of carbon dioxide. How many moles of carbon dioxide?
1.55.
Very good. Now, how am I going to convert those moles of carbon dioxide to grams of carbon dioxide?
I'm not sure, but moles would have to be on the bottom.
Very good. We always know that if we're trying to get rid of these units, the units have to go up there. Now, can I put grams up here? Do we know anything about the relationship there?
Oh, that's our molar mass. There's 44 grams per mole.
Very good. That's what they provided us with, right? 44 grams for every mole. So 1.55 times our 44 is going to tell us how many grams of carbon dioxide I have in 1.55 moles. Okay, here's another one. See if you can do this one at home. All right, push pause and see if you can do it. Then Fred will show us how to do it. Okay, Fred. How do we do this one?
I don't quite got the hang of it yet.
All right, well, what goes to the right of our equal sign?
Moles?
All right. It's not enough to say moles, though. What do we have to put in there?
I don't know.
You have to be specific. You have to go moles of carbon dioxide, okay?
Oh, okay, all right. Yeah, moles of carbon dioxide.
And that's very important because if you don't do that, then by the time you get to the point where you're lost, you have nothing to help you know where to go. This is your guidepost to tell you where you're trying to head. All right, so what units am I going to start with?
10 grams carbon dioxide.
Very good. And then I know I have to go from grams of carbon dioxide to moles of carbon dioxide. So I can see that, again, there's 44 grams for every mole. 10 divided by our 44 should give us our answer this time. Okay, very good. How about this? What mass in grams of this compound? Do you remember the name of this compound?
That's calcium phosphate.
Very good. What mass in grams would a 3.2 mole sample have? You folks tried at home before Fred helps us. All right, they pushed pause, Fred. They did it. Your turn now. Go for it, Fred.
Write an equal sign.
Okay, let's do it. Write an equal sign. What goes to the right of the equal sign?
Grams of calcium phosphate.
Grams of calcium phosphate. PO4, 2.
And you have 3.2 moles to the top left.
3.2 moles. And the more specific you are, the easier it is to not get lost. So now I'm going to go from moles of calcium phosphate to grams.
I haven't added it up yet. Do you have the periodic table?
Yeah, I can get you the periodic table. However, this little mm to the right there, what does that mean?
Oh, is that the molar mass?
Yeah, that's the molar mass.
Oh, that's nice.
Yes, that is nice. Very helpful. So 310.2 is a fine value there for the molar mass of the calcium phosphate. Okay. Very good. So 3.2 times the 310.2 for every mole there. And that'll be our grams of calcium phosphate. Was the answer up there? Whoops, 990. 990 grams. Okay, good. Okay, so now we're going to introduce the word stoichiometry. Although stoichiometry might sound like a German pastry or something like that, it's essentially what we've been doing already, so it's nothing terribly different. It is the relationship between the material and its individual components, or in a chemical reaction, the relationship between the amount of reacting molecules or compounds to the products, or the amount of atoms within the chemical. So it's these relationships. So for example, if I have 1 mole of sodium carbonate, I should have asked you for the name of that. This is our sodium carbonate here, right? If I have 1 mole of this, I have 2 moles of sodium within that mole of sodium carbonate. There's 1 mole of carbon in 1 mole of sodium carbonate, and 3 moles of oxygen in 1 mole of sodium carbonate, okay?
How can there be 3 moles of oxygen in 1 mole of something?
Nah, that's a good question. It's like I asked you to ask that question, because that does become confusing sometimes. And the thing is, when we talk about a mole of sodium carbonate, so if I have 1 mole of sodium carbonate, okay, there's the mole of sodium carbonate, and let's say I'm going to decompose that into its atoms somehow. Well, I'd get 2 moles of sodium, 1 mole of carbon, and 3 moles of oxygen, right? Well, that's like having a chocolate chip cookie, right? So here's my chocolate chip cookie. If I decompose it into its components, right? Let's say I have 4 chocolate chips for every 1 regular cookie or whatever, right? So I end up having 5 units that came together to make this thing. Here I ended up 3, 4, 5, 6 units that came together to make that thing, right? So yes, you will have multiple units coming together in compounds. And so in a way, you might feel like, wait, you're getting more moles out than you started with. But one is referring to moles of compounds, and the others are referring to moles of atoms within that compound. Okay? So, calculate the number of moles of sodium in 2.53 moles of sodium carbonate. Okay? So, we're going to get a clean sheet here. What goes to the right of our equal sign?
Moles of sodium, I guess.
That's right, moles of sodium. So I'm going to put that over here. I'm going to be specific, moles of sodium. And then I draw my line. What can I start with at the top left?
2.53 moles of sodium carbonate.
Very good. 2.53 moles of sodium carbonate. Okay?
Sodium carbonate down below.
Very good. We always know that, right? Moles of sodium carbonate.
Moles of sodium carbonate.
Down below here. And then what goes up here?
Moles of sodium?
Yeah. Now, do we know how to relate that?
Well, we said 2 moles of sodium for every mole of sodium carbonate.
Yeah, because I can look at the chemical formula, and just like I knew that there was 2 atoms of sodium, I can do that same thing here with moles and say 2 moles of sodium for every mole of sodium carbonate. Okay, very good. So my answer is just going to be the 2.53 times 2. All right, now if I want to calculate the number of atoms of sodium, I'm going to hijack this one. Instead of going to moles, if I go to atoms, it's just one step further. Now I'm in moles of sodium, and do I know how many moles of sodium or how many atoms of sodium are in a mole of sodium? All right.
No, we don't know that.
Well, we do, but we don't quite have enough familiarity with it maybe. But remember, if you have a mole of something, that's actually a number. What is that number?
Oh, yeah. I can't remember.
It's 6.02 times 10 to the 23rd. So if you have a mole of something, that's how many atoms of something you have. You can sometimes replace the word mole with the word dozen, for a while at least, till you're getting used to the word mole. So when you're stuck on a problem and it has the word mole in it, it might be because you don't quite understand what mole means. So if you replace that word with dozen, and think about a dozen being 12 for a little bit at least, and then you say, oh, I get what I need to do, and then replace the word dozen with mole and use, instead of 12, 6.02 times 10 to the 23rd. Okay, so if we do this problem this way, we should get 3.05 times 10 to the 24th atoms of sodium. Okay? All right, how many atoms of iron are in 15 gram sample of iron 3 oxide? What goes to the right of my equal sign? Yeah, push pause now if you want to try to do this one by yourself. What goes to the right of my equal sign?
Atoms of iron.
Very good. Atoms of iron. What am I going to start with?
15 grams of iron 3 oxide.
All right, 15 grams of... Now, I'm not going to write down the chemical formula for iron 3 oxide. You have to tell me what it is.
FeO3.
FeO3.
Or Fe3O. Or Fe... What does the 3 mean again?
The 3 refers to the charge on the iron. So essentially what we're looking at here is a compound coming together. I'll write this up here, okay? A compound coming together between an iron plus 3 and the oxide ion. Now, do you remember what the oxide ion does?
Oh, it's a -2.
That's right, -2. So, if a plus 3 charge and a -2 are going to come together, what's the resulting compound's formula going to be?
You can use the crisscross rule, and it's going to be Fe2O3.
Very good, Fe2O3. Now, if you didn't know what iron 3 oxide was, then that would be a big problem. Right? You would be stuck because you're not going to know how many moles of iron there are for every mole of iron 3 oxide. But here we got Fe2O3 grams, and we can go to moles because if we go to moles, then we can convert moles of Fe2O3, we can relate that to moles of iron. And then from moles of iron, we can go to grams of iron. Want to help me out with these numbers?
Let's see, the first one, the grams of Fe2 iron 3 oxide to moles, that's given there, it's 159.7.
So 159.7. How about this one?
Moles of iron for every mole of that stuff. I don't know, I can't figure that out.
Well, see, this is our statement, and we're just saying how many moles are there for every mole of that material. Or you can think of, if I had a dozen of these, how many dozens of irons would I have?
Oh yeah, okay, so it's just 2.
That's right, 2 of those for every one of those. Now, what about here?
Grams of iron per mole of iron? I don't know.
That's just that number on the periodic table, remember? We said that this number now is the grams of iron per mole of iron. Or whatever the element is, that's how many grams you need to get 1 mole of that material. So we're looking at 55.847. Okay, so 55.847 for every mole, and that should, oh, now I'm in grams of iron, but I need to go where?
Mole out of iron.
Very good. So I go grams, sorry, no. I made a mistake. I'm not going to grams of iron, iron here. I want to go to atoms of iron here. So that's not what we need. We need atoms of iron, right? So what do I need to go to atoms of iron per mole?
Oh, is that the long number?
Yeah, that's right. 6.02 times 10 to the 23rd. Good. So I saved myself because I saw that I was after atoms of iron, and I had thought I was going for grams of iron. Okay. So I went from moles of iron right to atoms of iron. Very good. Hopefully your calculator will get you the right answer if you follow 15 divided by 159.7 times 2 times 6.02 times 10 to the 23rd. All calculators are different, so make sure you give it a fair shot and try to get it. All right. Very good job.
Thank you.